Hello everybody, hope everyone's doing good. Today's session 5 is a continuation of session 4. Session 4, we have discussed a few problems and those problems were related to simple harmonic motion, uniform velocity and uniform acceleration and retardation. So in today's session 5, we'll discuss some of the problems related to followers motion. So as can be seen in the problem, they are given a cam with a minimum radius of 50 mm rotating clockwise at a uniform speed is required to give a knife edge follower. The motion is as described below. To move outwards through 40 mm during 100-degree rotation of the cam, to dwell for the next 80 degree, to return to its starting position during next 90 degree, and to dwell for the rest of the period of a revolution 90 degree. Draw the profile of the cam when the line of stroke of the follower passes through the center of the camshaft and when the line of stroke of the follower is offset by 15 mm. The displacement of the follower is to take place with uniform acceleration and uniform retardation. Determine the maximum velocity and acceleration of the follower when the camshaft rotates at 900 rpm. Draw the displacement, velocity and acceleration diagram for one complete revolution of the cam. So this is the problem that has been given. So few things to take care before starting the problem. So the first thing is that it can be clearly seen that the cam is rotating in clockwise direction and it is required to give a knife edge follow. They mention the type of follow. It is a knife edge. So the type of follower can be the knife edge, flat edge or a roller type. So it's clearly mentioned it is a knife edge follower. And they have mentioned the motion of the follower also. It moves outwards, that means through 40 mm. When they say it moves outward through 40 mm, that means the lift of the follower is 40 mm. So here the value of 40 mm is S, represented as capital letter S, during 100 degree of rotation of the cam. So this means that is the outstroke of the follower. Next, to dwell for the next 80 degree. Dwell means it is in rest, that is 80 degree. To return to its starting position during next 90 degree. So here return to starting position means it is a return stroke, and to dwell for the rest of the period, that is 90 degree. Now we need to draw the profile of the cam when the line of stroke of the follower passes through the center of the camshaft. That means the axis of the follower and axis of the cam are in line. Next, we need to draw the profile of the cam when line of stroke of the follower is offset by 15 mm. In the earlier problem that we have solved, here it can be clearly seen that they have mentioned the offset is 15 mm, but they have not mentioned the direction, whether the offset is on left side or on the right side. So when the direction is not mentioned, we are assuming that the offset will be on the right side. And also they mention clearly that the displacement of the follower is to take place with uniform acceleration and uniform retardation. So it is uniform acceleration and uniform retardation. We know that the follower motion can be of four types: either uniform velocity, simple harmonic motion, uniform acceleration and uniform retardation, or cycloidal. So here is clearly mentioned that the follower motion is uniform acceleration and uniform retardation. Next, they are given determine the maximum velocity and acceleration of the follower. Okay, they are given the camshaft rotates at 9 rpm. Also, they are mentioned draw the displacement, velocity, and acceleration diagram. So here we need to draw the velocity as well as acceleration diagrams for one complete revolution of the cam. So to draw the velocity and acceleration diagram, first we need to make use of the formulas and find the maximum velocity and acceleration during outstroke and return stroke, and the same values has to be pictorially represented. So read the problem. It's very important to read the problem carefully, and we should first check whether what's the type of follower, what's the type of motion, whether the cam is rotating clockwise or anti-clockwise, and all these things. So let's start with the solution. So let us write what has been given initially. So they have given S, that is the lift of the follower 40 mm, convert to meters. Then theta naught we know represents outstroke, is 100 degree, convert into radians. So here it can be done by 100 degree multiplied by pi by 180. So it gets converted to radians. Next theta R, that is return stroke, 90 degree. So convert that to radians again, 90 into pi by 180. Then find the given N, that is the speed, that is 900 rpm. First, let us start with the displacement diagram. So we know that for any displacement diagram, first we need to draw a horizontal line, and this horizontal line here, as can be seen in the sketch, it is AQ, and this AQ represents the outstroke, dwell, return stroke, and dwell. So as mentioned, what they have mentioned the problem, that has to be written here. Suppose if in the problem they have just mentioned outstroke, dwell, and return stroke, that only that has to be represented here. But in this particular problem they have mentioned outstroke, dwell, return, and also dwell, and also they have given the values. So represents those in the horizontal line AQ. So first here you can that is outstroke, that is 100 degree, is represented AS, dwell as ST, that is 80 degree, then the return stroke T and P, T to P, that is 90 degree, and finally the dwell is again for 90 degree, that is PQ. So all has to be represented to, as horizontal line on AQ, and take some suitable scale. Next, divide the outstroke and the return stroke, that is AS and TP, into any number of equal even parts. So here in the sketch it's given as 6. So 6 equal parts, that has to be divided. Once it has been done, draw vertical lines through these points. Draw the vertical points. So it's represented as 0, 1, 2, 3, etc. And same way you divide that return stroke also 6 into a person, draw the vertical lines. Now the height of these vertical lines will be equal to the stroke of the follower, that is 40 mm. Now we know this the type of the follower motion here is uniform acceleration retardation. So whenever we have uniform acceleration retardation, we have to take the midpoint of outstroke and return stroke. Here the midpoint of outstroke is 3 and the return stroke is 3 dash. Now this midpoint 3, that is a vertical line 3 and 3 dash, has to be again divided into equal number of equal parts, same as that of outstroke and return stroke. So it is 6. So divide the vertical midpoint line 3 and 3 dash into 6 equal parts and represent it as A, B, C, D, E, F, and again A dash, B dash, C dash, D dash, E dash, F dash. Once that has been done, now join, once that after that, join A, that is capital letter A to small letter A, B, A, C. So when you do that, A, B, and AC intersect the vertical lines 1, 2, 3 at points B, C, and D, as can be seen in the figure. Mark those points B, C, D and join them with a smooth curve. So this is the required parabola for the half stroke of the wall. Similarly, the other curves may be drawn accordingly. So as can be seen, join G to D, G to E. So when you draw those lines, it intersects the vertical line set 4 and 5. So mark it as E and F and complete the curve. So that represents the outstroke. Same way we need to do for the return stroke. So this completes the displacement diagram. Now once the displacement diagram has been completed, and in the problem they are clearly mentioned, we need to draw the velocity as well as acceleration diagram. So from the displacement diagram, from various points, that is A, S, T, P and Q, draw dotted vertical lines downwards. Next, to draw the velocity diagram and acceleration diagram, we need to calculate mathematically the maximum velocity during outstroke and return stroke, as well as maximum acceleration and maximum acceleration during outstroke and return stroke. Let us see how to do that. So we know that angular velocity of the cam omega, the formula is 2 pi n by 60. N has been given 900 rpm. Substitute those values, we get the answer. Next, we need to find the maximum velocity of the follower during outstroke, and here is given by formula V naught. So 2 omega s by theta naught. So we know the value of omega. S is nothing but the lift, that is 40 mm, convert into meters, and theta naught, that is the outstroke. They are given it as the outstroke is 100 degree. So we want in radians, convert into radians, that is 100 into pi by 180. So we had 1.745. Substitute those values, we get the answer. Same way, we need to calculate the maximum velocity of the following during return stroke. So here we are getting 4.0 meter per second and 4.8 meters per second respectively for outstroke and return stroke. So these values has to be transferred to the velocity diagram. Once that's been done, next we need to calculate the maximum acceleration of the follower during outstroke and return stroke. So A naught represents the maximum acceleration during outstroke, and the formula is 4 omega square s by theta naught square. So we know all these values. So substitute these values and we get the answer 467 meter per second square, and for the return stroke maximum acceleration we have 576 meter per second square. So these values again need to be represented pictorially in the acceleration diagram. Once that has been done, next we need to draw the profile of the cam. So here the type of cam, we know that is a knife edge. So as this is a knife edge, there is no pitch, there is no prime circle. Okay, there is no prime circle. So remember, we need to draw a prime circle if the type of follower is roller type. For knife edge and for flat edge, there is no prime circle, because the base circle and the prime circle are same for knife edge and flat edge. But remember, whenever there is a roller problem, we need to draw the prime circle. We will discuss that in later problems. So to draw the profile of the cam, take O as center and with radius equal to 50, that is the cam radius. Draw the base circle. Now divide the base circle into when the base circle represent the outstroke, dwell, and the return stroke. To do that, take OA as the base, use a compass and mark 100 degree, 80 degree, and 90 degree respectively. Once that has been done, divide the angle AOS, that is the outstroke, into 6 even parts, same as that of the displacement diagram, and angle also TOP, that is the outstroke, into same number of equal parts as in the displacement diagram, say that is 6. Now join the points, that is 1, 2, 3 and 1 O dash, 1 dash, 2 dash, and so on, with center O, and make sure that these lines that are drawn goes beyond the base circle. The lines of 1, 2, 3, 1 or O dash, 1 dash, 2 dash, it should go beyond the base circle. Next, once that has been done, from the displacement diagram, measure the distance 1b using a compass. After measuring the distance, come back to profile of the cam, take 1 as the center and cut an arc, that is point B. Same way measure 2c the displacement diagram and transfer that same to the profile of the cam with 2 as center, cut an arc that represents C. Same way transfer all the points, hence we get the points B, C, D, E, F up to P. Join all this with a smooth curve to the base circle. So this is the cam profile, that is A, B, C, D, E, F, M, N, P. This represents the profile of the cam when it is in line, when the axis of the follower and axis of the cam are in line. Next, let us see profile of the cam when the line of stroke of the follower is offset by 15 mm. As mentioned earlier, they have not mentioned the direction of the offset, so we'll assume that it is on the right side. The same procedure. So first we take O as a point, draw a base circle 50 mm radius. Next, measure 15 mm, draw the offset circle. Now from the center of O we can measure 15 mm, draw a straight vertical line, or through the right side of the offset circle circumference just draw a straight vertical line such that it passes through the base circle at point A. Now join O to A. With OA as the base, measure angle 100 degree, that is the outstroke, then 80 degree dwell, and again 90 degree as the return stroke. Again divide AO divide this 100 degree and 90, that is outstroke and return stroke, into 6 number of equal parts. And when drawing the lines, make sure that these lines are drawn tangent to the offset circle. Always it should be drawn tangent, and make sure that the lines that has been drawing through point 1 2 3 or O dash 1 dash 2 dash, it goes beyond the base circle. Same process, measure 1b, or from the displacement diagram transfer those values to the profile by using a compass. Hence we get the points B, C, D and F, G, M and P. Join all these points with a smooth curve. So this, when you join all this, the smooth curve, this represents the CAM profile. Okay. So thus we have completed the problem. Moving on to the next problem, they are given: design a CAM for operating the exhaust valve of an oil engine. It is required to give equal uniform acceleration and retardation during opening and closing of the valve, each of which corresponds to 60 degree of CAM rotation. The valve must remain in fully open position for 20 degree of CAM rotation. The lift of the valve is 37.5 mm and the least radius of the CAM is 40 mm. The follower is provided with a roller of radius 20 mm and its line of stroke passes through the axis of the CAM. So this is the problem. Let us go through the important points in this particular problem. It's given that the CAM, we need to design a CAM for operating the exhaust valve of an oil engine. It is required to give, here look here carefully, it is required to give equal uniform acceleration and retardation. That means the motion of the follower is equal uniform acceleration and retardation during opening as well as closing of the valve, and they are given the degree also, that is during the closing and opening of the valve is 60 degree of CAM rotation. That is the outstroke and return stroke is 60 degree. The valve must remain in fully open position for 20 degree. That means the valve will be fully open for 20 degree of CAM. That means that is a dwell. There is no movement of the follower. The follower will be at rest. So that is the dwell part. And the lift of the valve is 37.5. Lift of the follower is, that is S, is 37.5 mm, and the least radius of the CAM, that is the base circle, is 40 mm. They also provided, the follower is provided with a roller of radius 20 mm. That means the type of follower they are using in this particular operation is a roller type, and they mention the radius of the roller is 20 mm, and the line of stroke passes through the axis of the CAM. That means the follower axis as well as axis of the CAM are in line. So in this particular problem we need to draw the displacement diagram and also the profile of the CAM when it is in line. Okay, let's do it. So first we need to draw the displacement diagram as discussed in earlier problem. First draw a horizontal line AP, and this length AP will be equal to the sum of outstroke, dwell and return stroke, and draw it to a suitable scale. So here AS represents the outstroke 60 degree, ST represents the dwell, that is 20 degree, and TP represents the outstroke, return stroke, sorry, that is 60 degree. So we need to draw according to the given problem. So here if you total up the outstroke, dwell and the return stroke, it comes to 140 degree. So every time you need not draw a horizontal line equal to 360 degree. Okay, So in the problem, what they are measuring the values, those only has to be represented here. Now once the outstroke, well, and the return stroke has been represented, divide the outstroke and return stroke into equal number of even parts. So here it is 6. After dividing it, draw vertical lines through these points, and the height of the vertical line will be equal to the lift of the follower, that is 7.5 mm. Complete the rectangle box. As this problem is clearly mentioned, the follower motion is uniform acceleration and retardation. Hence, we need to take the midpoint of outstroke and return stroke, vertical line, midpoint vertical line, and divide that. Here in this case it is 3 and 3 dash. So this is the midpoint vertical line. Divide that vertical line, midpoint vertical line, into again 6 equal number of parts, as same as that of the outstroke and the return stroke, and mark it as A, B, C, D, E, F, and A dash, B dash, C dash, C dash, E dash, F dash. After that, join A to A to B, A to C. So when it join this A, B, A, B, A, C with lines, these lines will intersect the vertical lines at 1, 2, and 3. So represents the intersection points as B, C, and D. Join these points B, C, D by smooth curve. So this, by doing this, then we are drawn the half part of the outstroke. Same way, we need to join G to E, G to D, G to E, and these lines intersect the vertical lines 4 and 5 at points E and F, and join the smooth curve, these points. Hence, that is how the outstroke is parabola curve is drawn. Same way we need to draw when the valve is open. Once that is been done, it completes the displacement diagram. Next, coming to the cam profile, they have clearly mentioned that it is inline. So as I mentioned earlier, the type of follower is roller. So whenever a roller follower is there, we need to draw the prime circle, and the radius of the prime circle is the sum of, okay, repeat again, prime circle radius is equal to sum of the radius of the base circle plus radius of the roller. So in this particular problem, they are given radius of the base circle as 40 mm, and they mention the radius of the roller as 20 mm. So add 40 plus 20, 60. With O as the center, first draw the base circle of 40 mm radius, and again later with O again as the center, draw a prime circle of radius 60 mm. So once that has been done, divide the prime circle into outstroke, dwell, and return stroke as mentioned. So it is 60 degree, 20 degree, and 60 degree. Again, divide the outstroke, that is 60 degree, and the return stroke, that is 60 degree, into equal number of parts, even parts, same as that of displacement diagram, that is 6. Now mark these points as 1, 2, 3, 4, 5, 6, and O dash, 1 dash, 2 dash, and so on. And from point O, draw the lines to join these points. Make sure that the lines passes through goes beyond the prime circle. After that, measure the value from displacement diagram, that is 1b, by using a compass, and from the displacement diagram transfer that value to cam profile. We are taking 1 as center, draw an arc, it cuts at B. Same way, measure 2c from the displacement diagram and transfer it again here. With 2 as center, cut a arc, that is C. Same way we have to mark different points D, E, F, G, H, I up to P. Once that has been done, join all the arcs. Join all the arcs with a smooth dotted curve and connect it to prime circle. So this dotted curve is called as the pitch curve. Okay, it's called a pitch curve. Once that has been done, now we're taking A as a center, A, B, C, D as the center, and radius equal to 20 mm. That is the radius of the follower. Draw the circles. Draw the circles to at all the points. Once the circle has been drawn, join the bottom. Okay, join the bottom of all the circles. Okay, join the bottom of all the circles with a smooth curve to the base circle. Now once that has been done, that is what is called as the CAM profile. Okay. We need to join the bottom of all the circles to the base circle. So that represents the CAM profile. So this completes the problem. Next, we need to draw the profile of the CAM. So here, the type of CAM we know that is a knife edge. So as this is a knife edge, there is no pitch, there is no prime circle. Okay, there is no prime circle. So remember, we need to draw a prime circle if the type of follower is roller type. For knife edge and for flat edge, there is no prime circle because the base circle and the prime circle are same for knife edge and flat edge. But remember, whenever there is a roller problem, we need to draw the prime circle. We'll discuss that in later problems. So to draw the profile of the CAM, take O as center and with radius equal to 50, that is the CAM radius, draw the base circle. Now divide the base circle into when the base circle represent the outstroke, dwell and the return stroke. To do that, take OA as the base, use a compass and mark 100 degree, 80 degree and 90 degree respectively. Once that has been done, divide the angle AOS, that is the outstroke, into 6 even parts, same as that of the displacement diagram, and angle also TOP, that is the outstroke, into same number of equal parts as in the displacement diagram, say that is 6. Now join the points, that is 1, 2, 3 and 1 O dash, 1 dash, 2 dash and so on with center O, and make sure that these lines that are drawn goes beyond the base circle. The lines of 1, 2, 3, 1 or O dash, 1 dash, 2 dash, it should go beyond the base circle. Next, once that has been done, from the displacement diagram, measure the distance 1b using a compass. After measuring the distance, come back to profile of the CAM, take 1 as the center and cut a arc, that is point B. Same way measure 2c the displacement diagram and transfer that same to the profile of the CAM with 2 as center, cut an arc that represents C. Same way transfer all the points, hence we get the points B, C, D, E, F up to P. Join all this with a smooth curve to the base circle. So this is the CAM profile, that is A, B, C, D, E, F. So it's given what data has been given, write it down. They give mention the speed 1000 rpm, S 50 mm convert into meters, returns outstroke theta naught 120 degree convert into radians, again theta r 90 degree convert into radians. To draw the displacement diagram as discussed in the earlier problem, first we need to draw the horizontal line AV, and this AV represents the outstroke, dwell, return and dwell stroke as given in the problem. So mention all those values, that is 120 degree, 60, 90 and 90 degree for outstroke, dwell, return and dwell respectively to a suitable scale. Take a suitable scale to represent that line AV. Now here AJ represents the outstroke, JK represents the dwell, KU represents return stroke and UV represents the dwell. Divide the outstroke and return stroke into equal number of even parts, say in this particular scale it is 8. Draw vertical lines through these points, and vertical line height is 50 mm, that is the S, that is the stroke of lift of the follower. As in this problem the follower motion follows uniform acceleration and retardation, we need to take the midpoint of outstroke and return stroke. So here the midpoint line outstroke and return stroke is 4 and 4 dash. So divide this vertical line 4 and 4 dash into again equal number of parts, say 8. That 8 is equal to the how we have divided outstroke and the return stroke, same number of equal parts, and represent the midpoint vertical line division as A, B, C, D, F, G, H and A dash and so on. Next, join A to A, A to B, A to C and A to D. So when you join to these points, this A, B, A, C and A, D intersects the vertical line 1, 2, 3, 4 at point B, C, D and E. So join all these points with a smooth curve. Same way you continue, it has to be done for the remaining of the out stroke as well as return stroke. So after doing that, that will complete the displacement. Next, we need to draw the profile of the cam when it is offset by 20 mm. So as this is a roller problem, first we need to draw the base circle, and the base circle is given as 50. So radius is 50 mm. As here the follower type is roller type, we need to draw the prime circle. Okay, so prime circle is the sum of radius of the base circle and radius of the follower. So here the base circle radius 50 mm, so 50 plus and radius of the follower. In the problem they mention the diameter of the follower is 10 mm, so radius will be 5 mm, so it will be 55 mm. So with O as a center, first draw a base circle of 50 mm radius, and next again O as a center, draw the prime circle with 55 mm as the radius. Once that has been drawn, we need to draw the offset circle. So offset by 20 mm is draw 20 mm by 20 mm from the axis of the camshaft. Okay. So after drawing the offset circle, from point O, measure 20 mm and draw a vertical line upwards such that it intersects the base side of the prime circle. There you mark the point A. From O to A, join the line OA. Now with OA as the base, represent 120 degree, 60 degree and 90 degree. That is the outstroke, dwell and return stroke respectively. After marking 120 degree, 60 and 90 degree, divide the outstroke and the return stroke into equal number of parts, 8, as done in the displacement diagram. Now when joining the points 1, 2, 3, 4 or O dash, 1 dash, 2 dash by lines, make sure that these lines goes beyond the prime circle. Next, you measure 1b from the displacement diagram, transfer that distance to the profile by taking 1 as the center, cut a arc and I mark it as B. Same way you mark B, C, D and up to U. Join all these arcs with a dotted smooth curve to the prime circle. So this dotted smooth curve is called as the pitch curve. So in the sketch a mistake has been made. Okay, so the dotted curve is called as the pitch curve. Once the pitch curve has been drawn, take B, C, D, E, F, etc. R, T, U, like that as the center, and with radius of the roller, that is 5 mm, draw circles through all these points. Draw a circle with all these as the center points, that is B, C, D, E. Once the rollers have been drawn, join the bottom of these circles. Join the bottom of all these circles with a smooth curve to obtain the profile of the cam as shown in the figure. So remember, we need to join the bottom of all the circles with a smooth curve, and to the base circle it has to be joined. So this curve is called as the cam profile. So this completes the problem. So any doubts regarding this, please let me know, or by calling or messaging me. Thank you.